In this video, we're going to be looking at special right triangles. There are two right triangles which are looked at more than any others. They are the 45-45-90 and the 30-60-90. They are special because the lengths of their sides follow a simple pattern. In this lesson, we will be looking only at the 45-45-90 right triangle. Use the Pythagorean theorem to solve for x in the following triangles and see if you can determine the pattern. If you think you figured out the pattern, then you should be able to do problem number 5 without doing any work. Now, to do this, you're going to have to know the Pythagorean theorem. Do you recall what it is? Number 1. 1 squared plus 1 squared is equal to x squared. Expanding, we get 1 and 1 equals x squared. Simplifying further, we get x squared equals 2. And taking the square root of both sides, we get x equals root 2. I'll write the answer by the hypotenuse. Looking at example 2, using the Pythagorean theorem again. 2 squared plus 2 squared is equal to x squared. Expanding, we get 4 plus 4 is equal to x squared. Simplifying further, we get x squared is equal to 8. Taking the square root of both sides, we get x equals the square root of 8. The square root of 8 can be simplified further. X equals the product of, the square root of the product of 4 and 2. If we simplify further, we get x equals 2 square root 2. I'll write this answer by the hypotenuse. In our third example, the two legs are 3. So we'll say 3 squared plus 3 squared is equal to x squared. Expanding, we get 9 plus 9 equals x squared. Simplifying further, we get x squared equals 18. Square rooting both sides, we get x equals the square root of 18. We can think of 18 as the product of 9 and 2. So x ultimately equals 3 root 2. I'll write this answer by the hypotenuse. If we look back at the first 3 examples, we might detect a pattern. 1, 1, 1 root 2. 2, 2, 2 root 2. 3, 3, 3 root 2. Might you have a guess as to what the fourth answer is going to be? Let's do the Pythagorean theorem one more time. 4 squared plus 4 squared equals x squared. Expanding, we get 16 plus 16 equals x squared. Simplifying further, we get x squared equals 32. Square rooting both sides, we get x equals the square root of 32. 32 can be thought of as the product of 16 and 2. The square root of 16 is 4, so the final answer is 4 square root 2. So again, some of you at this point might have detected what the pattern is. Let's review. Sides of 1, 1 give us a hypotenuse of root 2. 1, 1, 1 root 2. 2, 2, 2 root 2. 3, 3, 3 root 2. 4, 4, 4 root 2. 57, 57. As you may have guessed, the answer is 57 root 2. We can summarize our findings in the chart below. If you're given a leg in a 45-45-90 right triangle and you want to find the hypotenuse, multiply the leg by root 2. Conversely, if you're given the hypotenuse and you want to go backwards and you want to find the leg, just reverse what we did here, and that is divide the hypotenuse by root 2.